Okay, we're starting with what they give us, or maybe you've got a couple other things and you start a different way. That's okay. I'm going to go ahead and start with the first statement. S is the midpoint of CD. Actually, I've got a couple triangles here, so maybe instead of doing that, we'll trace the triangles. I have triangle they named S to R to C, so I've got that triangle on the right, and then S to R to, so the bigger triangles is what we're looking at. So I need some corresponding parts from there. Can I get any from S being the midpoint of CD, segment CD? So if S is the midpoint of segment CD, I can say equals or congruent with the midpoint theorem, or with the definition of the midpoint or the midpoint theorem. But I'm going to use the midpoint theorem because I'm looking for corresponding congruent parts, and that'll get me congruency right away. So I'm going to say those two pieces there on each side of S are congruent. It's a reflection, so I need to make sure ds is congruent to D corresponds with C when it gets reflected. Something like that. Okay, so I've got one set of corresponding congruent sides. A couple to go. Actually, do 1 and no, 1 and 3 don't correspond. Well, I got to do something with 1 and 3. Let me say, I think a lot of you probably know there's one of those unspoken ones that they don't have to tell us. We have RS congruent to itself. So let's just write that down because that usually doesn't take very long, and a lot of you see that right away. And we'll worry about how to get this third one. So I have a couple sides. What can I do with the angle 1 and 3? Because they don't correspond. The angles that correspond are 3 and 2. So how do I get angles 3 and 2 to correspond, like to get them congruent? Well, if 1 and 3 are the same and 1 and 2 are the same, I could replace and say 2 and 3. Is there any reason why we would know angle 1 is congruent to angle 2? So I know that angle 1 is congruent to angle 3. Any reason why angle 1 is congruent to angle 2? What type of angles are 1 and 2? Oh, you know what? Those are corresponding angles, but I would have to know that the lines are parallel. So if they told me that line AB was parallel to DC, we could prove these triangles congruent because 1 and 2 would be the same, and if 1 and 2, we could eventually say that 2 and 3 would be the same, and they would be your set of angles, and then it would be, let's see what we'd have here then. We'd have angle, side, side, no. Oh, but you know what? If those 2 and 3 were the same, you could use the converse isosceles triangle theorem and get the sides the same. Wow, so that would be a little bit of work yet. If we knew the lines were parallel, we could do corresponding angle postulate, maybe get it in the right order, so we could say, you know, replacement rule or something, get that third set of angles, but that would be a swear word. We'd still have to say, we'd still have to use the converse isosceles triangle theorem and say that if the angles are congruent, those opposite sides are congruent. So then we could say it's an isosceles triangle by say, oh, just scroll down. Let's turn the pen back on. We could say that DR and CR are congruent, and then you could use, there's a lot of different theorems. You could use the, after that point, you've got more than you need. You have all three sides. You could do side, 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 angle, side, but, there's a big but. We don't know that those lines are parallel. I can't say that the corresponding angles are congruent. They look like it, and they could be, but we don't know for sure. In this particular one, as hard as it would be, even if we had enough information, there's not enough info without knowing that those lines are parallel or being given some other, we'd have to have some other part that we would know the same besides 1 and 3. Just can't do it this time.